Okay, so this is 7.3, number 90 from the textbook. So what we want to do is, part A is asking us to show that the area of the rectangle, this rectangle, is modeled by the function a of theta equals 64 sine 2 of theta. So first thing we want to notice is that here the radius is 8 centimeters. And that would make this line right here, which is also a radius, 8 centimeters. So what we want to do is we want to set some variables. So we could set this part, which is half of the length, and this part, which is the width, as x and y. Okay, and then we could define the area using that, which would be area of the rectangle would equal 2xy. Now, to find the x and y, we're given the really the hypotenuse of this right triangle that's formed right here. And what we can do with that is right triangle trigonometry. So we want to set x and y, we want to define them in terms of trigonomic functions. So we could do that by saying cosine of theta equals x over 8, right? X over 8, adjacent over hypotenuse, and then sine of theta equals opposite over hypotenuse. And then we manipulate that a little bit more, and then we get x equals 8 cosine theta and y equals 8 sine theta. And we'll plug this back into this original equation right here, and we'll get this. Area equals 8 cosine theta times 8 sine theta. And we'll manipulate this a little bit, and we'll get that the area equals 64 times 2 sine theta cosine theta. And what this part here really is, this is actually an identity. If anyone remembers that this is actually the identity for the double angle of sine. This is the double angle formula for sine. So we could simplify that to this, which is what we're trying to prove. So that's part A is complete. Now part B is asking us to find the largest possible area for such an inscribed triangle. So basically this here is an area function, and this can be modeled on a graph. And so here we look at the graph, and the maximum height is 64. That's also modeled by the equation where you can see that A, the amplitude, is 64, which would be the maximum value. So 64 is the greatest possible area. Now to find the dimensions, let's go back to the graph, and we could see on the graph that that y equals 64 when x is pi over 4. Okay, so then what we'll get is, if we think about a unit circle, the coordinates for x and y to get the angle of pi over 4 is root 2 over 2, comma root 2 over 2. So that's kind of our x, y value. And if we go back to this equation, we really just found cosine theta and sine theta. So what we want to do, we want to multiply both of those by 8. And we'll get 4 root 2 by 4 root 2. But one of them has to be multiplied by 2, and that's because currently we're only finding the area of this rectangle right here, half of the rectangle. So multiply one of those by 2, and we get 8 root 2 times 4 root 2, which would be the dimensions for the inscribed rectangle with the largest possible area, which would be 64. So if you actually put this part into a calculator, you'll find that this equals 64. And that's 7.3, number 90.